Hello friends, welcome to VK Lectures. In this lecture, we are discussing the Karnataka Set 2020 question paper, Physics, question number 11 to 20. Um, a simple question from probability. The three fair coins are tossed. Find the probability of getting one head and two tails. So write it in this form. So combination of three head over. So again combination of two heads. HHT, HTH, THH. So combination of two head is also over. Now combination of one head HTT, THT, okay, then TTH over the combination of zero head or 3T. So 1, 2, 3, 4, 5, 6, 7, 8. So 2 to the power 3, 8 combinations. Now we have to get one head and two tails. Wherever there is one head, you can take it. One head and two tails. From where you start writing the two tails? Here, one head, two tail. So here two tail, two tails. So 3 out of 8. So option C. Now here you have a matrix given A equal to 1 by 3 into all 1, 1, 1. Now some properties. There is a property of the matrix. If all entries are same, then lambda equal to trace of this matrix, and all other lambdas are 0, 0, etc. up to n minus 1, where n is the order. So it will have n eigenvalues. Out of that n eigenvalue, one eigenvalue will be non-zero, that is trace. So here what is the trace? That is equal to 3. So trace equal to 3. Okay, so what are the eigenvalues? Lambda 1 equal to 3, lambda 2 equal to 0, lambda 3 equal to 0. Now but look at the matrix A. You have to divide it by 1 by 3. Now when you divide a matrix by 1 by 3, its eigenvalue will get reduced by 3. So lambda 1 is equal to 3 by 3, that is 1. Lambda 2 is 0 again. Lambda 3 equal to 0. Okay. Now what is the question? Find the value of determinant of e to the power a. Determinant means, determinant is nothing but product of eigenvalues. Product of eigenvalues. Now if lambda 1, lambda 2, lambda 3 are the eigenvalues of this matrix A, what are the eigenvalues of e to the power a? That is nothing but e to the power 1, e to the power 0, and e to the power 0. These are the eigenvalues of e to the power a. So what is the determinant? Determinant is product. E to the power 0 is 1, e to the power 0 is 1, e to the power 1 is e. So determinant equal to e. So your option B. Now here most of them will have a confusion. We are taking 1 by 3 from any one of the rows or columns. Is it applicable, or is this 1 by 3 only for this row, any one of the row? No, this is for all matrix. Now when you are dealing with operations on matrix, operation means matrix operations like changing row, taking 1 by 3 out of a row, then it is given only from one row you will take out the common, but this 1 by 3 is common to all the matrices. Similarly, if you take the determinant of this matrix 1 1 1 1 1 1 1 1, then this determinant is nothing but 0. Right, so this is also product of lambda 1, lambda 2 and lambda 3. Lambda 1 into lambda 2 is nothing but 0. Okay, then if you divide by 1 by 3, then the determinant this lambda also will reduce by 1 by 3. So lambda by 3 into lambda 1 by 3 into lambda 2 by 3 into lambda 3 by 3. So this is the determinant. If this one of them was not 0, you would get a value in this way. Okay. A particle thrown upward from Earth's surface reaches a height of 100 meters and returns back. The acceleration of the particle at its highest point of reach has a value. Now, this is the scenario. We have a particle, and this particle is moving at a above height and then coming down. Now the question is, at this point, what is the acceleration? This is 100 meter above. Okay. Now, at this point we know velocity equal to 0, because it reaches maximum height, its velocity will be equal to 0, and then it descends down. Then what about acceleration? The acceleration will remain same. It is 9.8 meter per second square. It will be g. Now suppose, if you have any doubt, just look into this scenario. Suppose acceleration is equal to 0. Okay, if acceleration equal to 0, then let us take the force. Force is equal to mass into acceleration, that is equal to 0. That means force on this particle when it reaches this particular position is 0. If the force on this particle is 0, that means the particle is stationary, that is in equilibrium. Stationary, there is no external force, means it is stationary. If it is stationary, means it is standing in the mid-air. It doesn't happen, it is falling down. Now assume it is not equal to gravity, not equal to or acceleration not equal to gravity. In that case, what happens is, it will the time of flight, time taken to reach from this point to this point, for example if it is t, time taken by particle to reach from this point, let me tell A to B, if time taken is from A to B is equal to t, then time from B to A will be equal to t dash, if there is a change in acceleration. But we know time of flight is same. Time of flight means it's not a complete, like A to B will be equal to this, t dash must be equal to t. That is one part of the question. I mean, this is what it is. Now another idea, if on the surface at any point, if you go above, if you reach height above the ground, there is a difference in acceleration. The acceleration at this point is not equal to acceleration at this point. There is a change, but that change is very negligible. Depends on the height change. Now as you go down the earth, then also there is change in acceleration. What is that change? If you go up, the acceleration g dash is equal to g into 1 minus 2h divided by re, where re is the radius of earth. around 6.4 into 10 to the power 6 meter. Okay, now as you go down the earth, then also there is change in acceleration, that is given by 1 minus 2 not 2, there is h divided by r, there is no 2. So when you go down the earth also changes, when you go up the earth also changes. There is gravity even on international space station, there is gravity. Even though we see people floating, it is still there is gravity due to earth. So this is what it is. Now in this question, if you put this height h equal to 100 meter, this is just 10 to the power 2 comparable to 10 to the this re, this value is very small, so our g dash will be almost equal to g. That is why in this question, but this question is an entirely different. This is not asking about what is the change, what will be the gravity at that point. Okay, so option is D. Suppose the radius of the earth were shrink by 1%, its mass in the mass is remaining same, and acceleration due to gravity would be. Now what is the formula? G is equal to capital G by into m divided by r square. Now if there is a change in delta G, the G is constant, and change in delta m into r square, that means 2 times change in r, which means what? If there is 1% change in mass, there would be a equivalent 1% change in gravity, and if there is 1% change in radius, there will be an equivalent 2% change in gravity. Here radius should be same, here mass. Suppose in both, for mass there is 1% change, as well as for this radius there is 1%, their equivalent change will be 3%. Now if this formulas or this idea doesn't stick to your mind, you can go for usual method, that is assume our values are some constants gm by r square. Now for this time being, we will take capital G, m and r are 1. Okay, so if g, m and r equal to 1, then our gravity is nothing but 1, acceleration due to gravity is equal to 1. Okay, now if there is a 1% change in 1% change in r, so our g is equal to this 1 and 1 would remain same. Instead of r square we have 0.99, instead of 1 we have 0.99. there is 1% change, so this is nothing but 1 divided by 0.9801. 99 square is 9801. This value is nearly equal to 1.0203. Okay, now earlier you had 1, now you have 1.0203. what is the change? 0.0203. this is the change with respect to 1. So what is the percentage change? Just multiply by 100, so it will be 2.03%. so it is increasing by 2%. now how to say whether it is increasing? Because it is inversely proportional. Inversely proportional. If the differential cross section in a scattering is equal to a square, where a is a constant, then total cross section. So what is given here? Here d sigma by d omega is equal to a square is given. This is the differential scattering cross section. Now what is asked? You are asked to find out sigma, the total cross section. So what you have to do, sigma is equal to integral a square d omega. That's equal to integral from where to where? 0 to pi. So integral 0 to pi a square d omega is nothing but 2 pi sine theta d theta. So 2 pi a square will come out because this is a constant. So 2 pi a square into integral sine theta d theta 0 to pi. This value is nothing but 2. Now we'll see that 2 pi a square into sine theta minus cos theta. From where to where? 0 to pi. Cos theta, from since it is minus, we will go with lower limit. So 2 pi a square into cos theta 1 minus cos pi minus 1, that's equal to 4 pi a square. So your option D. So you have to remember this formula, differential cross section formula, and as well as total cross section formula. Center of mass of an L-shaped uniform wire as shown in figure, OA equal to OB equal to L is set. So this is a problem on center of mass. So let us see, if there was only OB, then center of mass would be at this point, right? That is what is the coordinates on 0, x-axis 0, comma L by 2, right? And now let us see, if only OA was present, here it would be the center of mass. So what is the coordinate of that center of mass? L by 2, comma 0. This is the individual center of mass for each length. Okay, each rod, the center of mass. Now center of mass of the system, center of mass of system, how do you give represent? X center of mass is equal to mass into L by 2 plus another mass into 0 divided by m plus m. This is x coordinate, and similarly you can write y coordinate, mass into 0 plus m into L by 2 divided by m plus m. Why m plus m? Because these both rod have mass m and both are uniformly distributed mass. Uniformly distributed. So what is xcm? M L by 2 divided by 2m. So that is equal to L by 4. Here m L by 2 by 2m, that is L by 4. So L by 4 comma L by 4 is the center of mass. So your option is B. If the Lagrangian of a mass m is given by, so Lagrangian is given, and you are asked to find out x. So let us write the equation of motion, Lagrangian equation of motion. Total time derivative of dou L by dou x dot minus dou L by dou x equal to 0. Now this is equal to d by dt of, what is dou L by dou x dot? 2 mx dot by 2, that is equal to mx dot minus, what is dou L by dou x? Okay, that is equal to f equal to 0. What is total time derivative of mx dot? That is nothing but mx double dot minus f equal to 0. From here we will get x double dot is equal to f divided by m. Now x dot, so what is x dot? Then x dot equal to integral x double dot with respect to time. X dot is nothing but dx by dt. X dot is equal to dx divided by dt. And what is x double dot? D square x divided by dt square. Okay, so x double dot into dt. What is that? F by m into t plus some constant c1, right? Some constant c1. Now we want x, right? So once again you have to integrate this. X equal to integral x dot dt. That is equal to, what is x dot? F by mt plus c1. So integral x dot will be f by m t square divided by 2 plus c1t plus c2. So f by 2m into t square, f by 2m into t square. So option C. A body of mass m moves in a circular orbit of radius r in a potential v of r is equal to minus k by r, where k is a constant. Then orbital angular momentum about the center of the circle. So orbital angular momentum L is nothing but mv into r. Now what is given to us is v. V is equal to minus k by r. What is force? D by dr of v. That is nothing but k divided by r square. Right. So force, but we already know mv square by r is equal to k divided by r square. From this we can take v is equal to, or v square is equal to k divided by mr, or v is equal to under root k by mr. Now what do we want? We want is L is equal to mv into r. Now just substitute this v here. M into, what is v? Under root k divided by mr into r. So what you get is under root mkr. Alright, so your option C. Identify the correct Hamiltonian equation of motion from the following. It's a direct question. Q dot is positive, P dot is negative. So this is your option C is your correct answer. So what is Q dot? Q dot, you can, it is not exactly, we do not know, but you can take it as x, a coordinate x. So Q dot will be x dot, which is nothing but v. Just for comparison I am giving you these ideas. Now what is P? That is nothing but momentum mv. That is nothing but mx dot. And what is P dot? That is nothing but mx double dot. Okay, so this, what is this? X dot is nothing but velocity. This is nothing but force, right? So velocity and force, just giving you an idea what it is giving you. What do you mean by Hamiltonian equation and what does it give? Q dot is dou H by dou Pi. P dot or Pi dot is equal to minus dou H by dou K. So please remember this. If the potential energy of a body is given by V of x is equal to x square minus 4x plus 4, the point of stable equilibrium. Now, how will you find out this? So what you have to do is find out V dash. So what is V dash? First derivative of V with respect to x is nothing but 2x minus 4. Now V dash, when you equate it to 0, you get stable points. V dash, when you equate to 0, you get stable points. Okay. Now V dash equal to 0 implies 2x minus 4 equal to 0, that is equal to x equal to 2. Now you have to verify that at x equal to 2 you have a stable point. Now x equal to 2 you have a stable point, whether it is, x equal to 2 you have an equilibrium point. Now whether it is stable or unstable, we have to find stable or unstable. For that you have to take the second derivative of v, that is nothing but 2x minus 4, 2x minus 4 v dash, that is, so that will be equal to 2, v double dash equal to 2. Now if this value is greater than 0, this is a stable equilibrium. If this value is less than 0, it is unstable. Okay. And in between there is point of inflection also. Point of inflection, not inflation, inflection. Okay. So now you got at x equal to 2 it is a equilibrium point, and now you also proved that that point of equilibrium is a stable point of equilibrium. So x equal to